Alright, so today what we're going to do is we're going to take a look at two-way frequency tables, also called contingency tables. This is a way to display bivariate categorical data. Now that sounds pretty fancy, but bivariate just means two variables, and categorical just means we're going to be in categories. So it's not necessarily going to be a number answer like how many brothers do you have, how many sisters do you have, but it's going to be like your favorite color. So let's look at a couple of vocabulary words. The first is marginal frequencies, quantities that are in the margins or the totals of the table. We're going to look at an example in just a minute, but remember, marginal frequencies are ones that are in the margins or the totals of the table. Joint frequencies are quantities that are in the body of the table. It's going to be a quantity that represents both categories that we're looking at. And lastly, we have conditional frequencies. These are going to be quantities based on one category that's already chosen. Please make sure this is filled in into your interactive notebook. Now, let's look and see what these things mean. All right, so we have this example right here. It's surveying friends about the type of party that they enjoy most. So if we think about category 1 is whether they are a male or female. Okay, so that's going to be an answer. And then category 2 is going to be what party type they like best. And of those choices, they have bowling, skating, or dancing. So that's why this is a two-way frequency table, because we're going to be looking at whether they are male or female and what kind of party they like. All right, so let's look at our vocabulary words. The one in the oval here, the 6, 2, 3, 11, 1, and 3 is the body of the table. All right, it's the body because it talks about both the male, female, and then what kind of party type they like. That's going to be a joint frequency. So let's add that. Let's make it a different color. So the body of the table is going to be a joint frequency. Okay, because the number 6, for example, is joining two things. It is a male who also likes to bowl, or 3 is a female who also likes to dance. Okay, so the body of the table is going to give us a joint frequency. All right, the next thing that we're going to look at is the margins or the totals. So for example, right here, we have 8 total people like to bowl, or 14 total people like to skate. Or if we look down here, 10 total people are males. So these are called the margins or the marginal frequencies. The last thing that we've got is the grand total here of 26 people. So if we added the total of parties, 8 plus 14 plus 4, we would get 26. Or if we added the totals of the males and the females, we would also get 26. All right, so we have 3 types of probabilities that we're going to find here. A joint probability, which is going to be a number in the body over the total. A marginal probability, which is going to be a number from the margin over the total. And a conditional probability, which is going to be the body over the margin. Now, this may look confusing now, but we're going to look at some examples and simplify. So we're going to use our frequency table that we came up in class the other day. So the question is, what % of students are male and prefer SpongeBob? This word right here, and, is key. We're going to be looking at something from the body of the table. So let's find SpongeBob as this column, males are this row, and so we look to see where do they overlap? They overlap right here. So we know that 2 out of the total 21 are male and prefer SpongeBob. Now, you can leave it as a fraction, but the question did say what %. So if I divide 2 by 21, that gives me approximately 0.10. And then if we change 0.10, which is a decimal, into a %, we get approximately 10%. So 10% of the students are both male and prefer SpongeBob. Since we were comparing it to the total and we used one of the numbers in the body of the table, we're going to call that a joint probability. All right, so let's look at a slightly different question. This is saying what percent of the males prefer SpongeBob? So what category do we care about here? Well, it says what percent of males, so the only thing I want to look at here on the table is how many males there are. So I'm going to line up my table. Here's my male column, and I'm going to go all the way to the end, and I can see that there are 8 total males. So that's going to be my denominator, or my whole, that I'm comparing to. Now, how many of those 8 prefer SpongeBob? So if I look at just the males, we have 2, so it's going to be 2 out of 8. Now you can leave it as this fraction, but sometimes on a multiple choice answer, it might turn it into a reduced fraction, so that would be 1/4. If we turn 1/4 into a decimal, that's going to be 0.25, which is also the same thing as 25%. So you might see your answer in all 4 of these formats. So again, our denominator changed because it said what percent of males. So we didn't care about the females in this problem. Well, since all we cared about were males, we're going to call this a conditional probability because it's based on the fact that they have to be a male first. Now remember, this is different. Our last one said what percent of students. So we were comparing to total students on this one. Here, we care about what percent of males. All right, let's take a look at one more. The last one said, what percent of students are male? So our category here that we're looking at is students, so we want to use our total again. So that's going to be 21 in our denominator. That's our whole. Now of those students, how many are male? Well, we've got our 8 total males. So I'm going to write that as a fraction as 8 over 21. Now I'm pretty sure that doesn't reduce, but we can turn that into a decimal. So 8 divided by 21 gives us 0.38. And if I want to turn that into a percent to answer the question the way it asked, it's going to be 38%. So we used our total of 21 in the denominator, but notice we got this male version right here of 8 from the margins. So we call this a marginal probability. All right, let's get to some practice.